In this unit, we are going to talk about ways that we can manipulate different types of functions. So we're going to start with polynomials. We're going to talk about polynomials for a week or two, maybe. Then we're going to talk about different ways that we can rewrite or manipulate log or exponential functions. We're going to talk about different ways we can manipulate rational functions. So we're going to talk about manipulating all different kinds of functions, okay? Different ways I can combine them or rewrite them depending on what it is I'm trying to find or what it is I'm trying to do. We're going to need to be able to have some sort of fluidity and flexibility with our representation for our function. So that's what we're going to focus on in this unit. We are starting again with polynomials, and today we are doing three things with polynomials. We are going to add them, we are going to subtract them, and we will multiply them. Okay, these are all things that you have done before to certain degrees. The difference will probably be that we're looking today at higher powers of x than you maybe looked at in Algebra 1, okay? So for example 1, we are adding two polynomials, right? Here's one polynomial, 5p squared minus 3, and another one, 2p squared minus 3p cubed. When we are adding polynomials, we are just combining like terms. That's it. Nothing fancy. We are just combining like terms. So I can see here that I have a p squared and another p squared. Those are my like terms that I'm going to combine. Okay. Where I tend to see the most mistakes on these polynomial problems is we see two things in parentheses and we just start distributing. So make sure that you are paying careful attention to the sign that you have there. Okay. I am adding these two polynomials. So this would be 7p squared. And then this doesn't have a like term, this p cubed. And I like my polynomials to be in what's called standard form, where the exponents are arranged in decreasing order. So I'm actually going to throw that one in front since it's got a higher power. And then I've got a constant term here, no other constant term, so that's it. For example 2, we are subtracting. Be careful with your signs when you subtract. You are subtracting every term in this second polynomial, not just 3a squared. You are subtracting all of the terms that come in that second polynomial. For problems where I am subtracting, I personally prefer to rewrite the polynomial I'm subtracting with the subtraction in there. Minus a negative means I change that to a positive. So now I'll combine terms from here. Okay, that's my way to make sure I don't make sign errors. Okay, sign errors, super common. Alrighty, so we've got a cubed plus 4a cubed. That would be 5a cubed. And then I've got negative 2a squared and negative 3a squared. That would be negative 5a squared. Not too bad. Okay, these shouldn't be too terrible. When I have longer polynomials, you potentially have more like terms to combine, but the process is exactly the same. So on example 3, since we're subtracting, remember that means I'm subtracting every part of this polynomial. Again, I like to rewrite it with that subtraction in there so that I don't make sign errors. And then once I've got that rewritten, I am combining like terms. Again, I like to put my polynomials in standard form. That means the variable with the greatest exponent goes first, and then I put my terms in descending order based on that exponent. So I'm going to look for my biggest exponent. That would be 4. So I'm going to start by combining my n to the 4th terms. Negative 3 and negative 11 would be negative 14 n to the 4th. And then I don't have an n cubed. I do have n squared. 10 minus 3 would be 7n squared. And then here's a term that is just n plus 8n and a constant term plus 7. For example 4, where we're adding, I don't have to worry about changing all the signs. We just combine our like terms as they are. My biggest exponent looks like x to the 5th. So this would be 18 x to the 5th. And then I've got x to the 4th and x to the 4th. So that would be plus 6x to the 4th. And then 6x cubed and 6x cubed would be plus 12x cubed. We had a unit, not our last unit, but the unit before that was on domain, okay? And we said the domain of a polynomial is all real numbers, okay? So if I look at my individual pieces here, this polynomial and this polynomial, right? This guy's gonna have a domain of all real numbers. So will this guy. What about their sum? What would be the domain on this guy? Still all real numbers. It's still a polynomial, right? What about when I subtract? This domain would be all real numbers. This domain would be all real numbers. How about for the difference? The domain would be still all real numbers, right? When I add and subtract polynomials, our end product is going to be, or our end result, I should say, product means multiplication. Our end result is going to be another polynomial, okay? So that's what we call a like closed system. Polynomials are closed under addition and subtraction, okay? Since we talked about domain already, I wanted to make sure that we talked about that really briefly, okay? That when I add and subtract those polynomials, the domain isn't going to change. I still end up with a polynomial. So we talked about adding and subtracting. Let's talk about multiplying. Okay. When we talk about multiplying polynomials, what we're talking about is typically some distribution. We're going to see distribution here. Okay. I am going to show you a couple of different ways that you can organize your distribution. I'm going to guess that most of us, when we learned distribution, did something like this, right? The little like kind of arches over the top of your problem. Yeah, and that's fine. That's how I tend to do distribution, but I do want to show you something else as well. So let's work through this first problem. When I distribute, I'm multiplying. I'm saying take this term and multiply it by every term in the other polynomial. So that negative 3x times 4x squared. If I multiply the numbers, I get negative 12, and then x times x squared would be x cubed. Be careful with your exponents. And then we multiply again. Negative 3 times 6 would be negative 18xy. They're staying separate because they're not the same. And then negative 3x times negative 8 would be plus 24x. I want to show you one other way that you can organize your work for a problem like this. It's called the box method. Actually, we'll do the box method on example 7. So let's hop down to example 7, and I want to show you something called the box method. For some people, it's difficult to keep track of all of the multiplication when you hit a bigger problem. So what we can do is to set up basically like a table. And I decide the dimensions of my table based on the polynomials that I am multiplying together. So this time I have a binomial times a trinomial. So I want my table to be 2 by 3. I'm going to take each term from my binomial and line it up along the side that's 2. Be careful with your signs. Make sure that negative sticks with the 4x. And then I'm going to do the same thing with my trinomial. Each term gets a space along the top. I am keeping those signs, the plus 2x and the plus 7, I'm keeping those with my terms because when it's subtraction, that sign is really important, right? If it were minus 2x, I would need to make sure I keep the negative. So I just get in the habit of keeping it with the positive as well. And then what I'm going to do is, have you guys done Punnett squares in biology for traits? It works just like a Punnett square, okay? So what I'm going to do to fill in the box is multiply the terms that are on the outside edges. So this guy would be 3x to the 4th. And then I would have 6x cubed and 21x squared. Here, x squared times negative 4x would be negative 4x cubed minus 8x squared minus 28x. And then my final answer would be all of these terms, like terms combined, written out in standard form. So I have 3x to the 4th, and then here are some like terms that would be plus 2x cubed. And then here's another set of like terms that would be plus 13x x squared minus 28x. This is an option I wanted to show you. For these bigger problems, we end up with a lot of little arches everywhere. And for some people, that's difficult to keep track of. If you like the box method, go for it. If the box method is not for you and you prefer that sort of traditional distribution setup, that's fine too. But I did want to show you what that looks like. Let's go back to example 6. And we've got some more distribution here. So for example 6, I've got a monomial, a single term thing, a constant that we are going to multiply into this binomial. So this would be negative 2x squared minus 10x. And then I've got some distribution here as well. I'm actually going to distribute in negative x squared. That way I carry through that subtraction. So this would be minus x cubed minus 6x squared. And then we combine our like terms. X cubed is going to go first, since that's my biggest exponent. And then I've got negative 2x squared minus 6x squared. That'd be minus 8x squared and minus 10x. For our last example on the first page, where's the distribution here? Where's the multiplication? Mm-hmm. Yeah, we have a square here, okay? And remember that a square, you phrased that perfectly, a square means this thing times itself, okay? That means that it's not x squared plus 4. I have to do x plus 2 times x plus 2. If you want to try the box method on this one, it would be 2 by 2, x plus 2, x plus 2. If you are a traditional distribution person, this would be x squared plus 2x plus 2x plus 4. And I'm going to combine my like terms here, and I get x squared plus 4x plus 4. There's one other part to this problem that is tricky. What is the operation that we are doing? Subtraction. So since I am subtracting this, I'm actually going to go ahead and change all those signs and then combine my like terms. This would be negative x squared, and then 9x minus 4x would be plus 5x. 7 minus 4 would be plus 3. And then we talked about domain when I add or subtract these polynomials. We said when I add 2 polynomials, the sum is a polynomial. If I subtract 2 polynomials, the difference is a polynomial. What about like example 7 where I was multiplying 2 polynomials? What's the result? What kind of function is that? It's also a polynomial, right? So what would you expect the domain to be for the product there? All real numbers, okay? Same idea. Okay, we are gonna stop there for today. You have some practice on delta math.